Hi, today we're going to be going over the Java solution for Leetcode 33, search in rotated sorted array. So without further ado, let's go through with the problem. There is an integer array num sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index. So such that the resulting array is, so for example, 0, 1, 2, 4, 5, 6, 7. So this is sorted, might be rotated at the pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. So this is telling us basically the last element got moved to the first and everything got shifted accordingly. So you can see how, this is still sorted and this is still sorted. It's just that there's sort of like a break in the middle, but overall these things are sorted, but as the name suggests, they're rotated. Given an array nums after the possible rotation and an integer target, return the index of the target if it is in nums, or -1 if it is not in nums. Write an algorithm with O of log n runtime complexity. So, going over example 1, you can see that it is a rotated sorted array. And basically our target is 0. We have to go through it, find 0. We see that it exists, and we can return its index, which is 4. With example 2, our target is 3. It's the same array, and it doesn't appear, so we can return -1. And then same thing with the last example. So first of all, it's always nice to get the brute force solution out there. And for any sort of search in the array problems, that brute force solution is going to be O of n runtime complexity or linear, since it's just going to be us looping through the whole array, basically trying to find does it exist or does it not. So we can do if nums of I is equal to the target, then we know we found it, so we could return I. Else we can return -1. Well, not else. Return -1. So let's see if this works. And great, it does work. So again, this is a brute force solution. Looking at the problem, there are two sort of hints that give you what you're supposed to do. Number one, it is a sorted array. It is some sort of sorted array. And number two, we must write an algorithm in O of log n time complexity, which tells us we're going to be using binary search. Binary search works in sorted arrays, and it works as a O of log n runtime algorithm. So what are our steps going to be? What is our game plan? Step 1 is going to be basically figure out the index of the minimum element in O of log n runtime. So what is this? What do I mean by this? Basically, we're going to figure out the index of the minimum element. So another way to phrase this, if this wasn't rotated, what would be the beginning element? So, this would be 0. It is also the minimum element, and we specifically want its index. And the reason why we want to do it is because figuring out that index will break this apart into two sort of sections, and each section is going to be sorted. So this section is sorted 4, 5, 6, 7, and this section is sorted 0, 1, 2. So this means we can perform binary search in whichever section to find our target. So that's the main reason why, and it has to be done in O of log n complexity at least, or at most, I guess. So if it's faster, it's better, but at minimum, it has to be O of log n. Just because if we were just linearly searching through it to find it, then that would just mean that it's O of n runtime. Step 2, after we figure that out, figure out which section it's in, which section the target is in. So, is the target in this sorted section or this one? So this way, we just have to perform binary search on one of these instead of both of them. And then number 3 is basically perform binary search in that section. So this is our game plan. This is what we're going to do. So how are we going to do step 1? Step 1 is just going to be a variation on binary search. It's going to use the same sort of binary search template, but we're just going to mix up a few things. So I'll set up a binary search template. So we have our lower bound, we have our upper bound, and we'll make our while loop. And then we'll say int mid is equal to I plus j minus I divided by 2. So This is the same thing as saying j plus I divided by 2. It's just that this avoids the integer overflow error. And now, instead of saying, oh, is nums of mid equal to target, we're going to say, is nums of mid greater than or equal to nums of j. So why are we doing this? Let's say it is greater than nums of j. So if we use example 1, the integer array in there as an example, our lower boundary in the first iteration would be 4, our upper boundary would be 2, and our mid would be 7. Now we're comparing it. Is it greater than j? Is it greater than our upper boundary? Because if this section right here was sorted, then that would mean the elements ahead would always have to be greater than the elements below. So if the mid, if this in element is greater than this, then we know there's some sort of continuity break happening in this section. So our minimum element is gonna be here. So we can just bump up our I, our lower boundary, to be mid plus 1. Else, it's the complete opposite, and so we can lower our upper boundary. And now I, our variable I, that is going to tell us the index of this minimum element. So how can we use this information? Well, let's set up two other variables, int start and int end. So these two variables, what they do is that these are going to be our upper and lower boundary for the binary search we're going to perform to find the actual target. It's just that we're going to modify them to see, is our start going to be here, the first index, or is it going to be the index of the minimum element, and is our end going to be here or the last element. So we can test it to see if the target is greater than or equal to nums of I, and target is less than or equal to nums of nums.length minus 1. Then what does this tell us? Well, let's say our target was 1. In that case, it is greater than nums of I, or our element 0, and it is less than or equal to this ending element, the last element as well, which means that our 1 must appear in this sorted section. If that wasn't the case, then that means our 1 or our target would appear in this other section. So we can set our start to equal I and our end to equal nums.length minus 1. And in this other case, our end would just be I and our start would be 0. So this is just going over the two possibilities to see which case we're working with. I'm going to lower this down. And now we have our lower and upper boundaries to perform binary search. So let's just do that. So while start is less than or equal to end, int mid is equal to start plus end minus start divided by 2. And then we can say if nums of mid is equal to the target, then we can return the mid. Else, if nums of mid is greater than the target, then we know we highballed, which means we could set our j is equal to mid minus 1. Else, we lowballed, so we could set our, or not j, our end. And then we can set our start to equal mid plus 1 in the case that we lowballed. And then else, then it doesn't exist at all in this array, so we could just return -1. So let's see if it works. Okay, great, and let's submit it. And there we go. So that was, here's basically the full solution if you want to look at it. So that was Leetcode 33, search in rotated sorted array.